let's
Well,
wait for a while for more people. Yeah, I believe somebody will join us. And
yeah, sure. Let's give a couple minutes.
okay. Okay, so today let me share the screen and then okay, so today we will discuss retrieval augmented generation, function calling, and agents in state-of-the-art approaches for create useful frameworks with large language models. It's necessary because in large language models, we still have some hallucinations, and these models can create not correct answers. It would be not true answers. If we want to rely on specific documentation, we can do it with retrieval augmented generation. So in short, we can name it RAG, and RAG combines the strengths of retrieval systems and generative language models. Retrieval systems, it's mean when you create embeddings and you can search for the similar texts. You create embeddings from the texts, and then you can create embedding from specific text that you need and search the closest embeddings in the latent space. So we tried to create a search engine with Mistral API. I think it was when we discussed large language models topic, but part 2. It was on our lesson with code. So yes, instead of relying solely on models parameters for generation responses, RAG retrieves relevant context from an external knowledge base or document set. Let's discuss key components of retriever. So responsible for finding the most relevant documents or chunks of the text based on query, and there are common techniques for this. Dense retrieval, when we use embeddings and vector similarity, for example, with FAI's technology, or sparse retrieval, traditional methods like TF-IDF or BM25, based on frequency of searching specific words in documents. For example, FAIS searches text embeddings for the closest matches to a query, and we create a retrieval system with this. Also, we have a generated model in our components. And we can use decoder-only large language models that we studied on previous lessons. And it would process the retrieved context to produce an answer. It will require prompt engineering to blend retrieved context with user queries effectively. And there are some advantages in this technique. For example, improves factual accuracy by grounding responses in up-to-date external knowledge. It reduces hallucinations by focusing on variable information, as I mentioned this in the beginning. And also it supports dynamic updates as the retriever can adapt to new data. We can use it in chatbots, for example, with domain-specific knowledge. We can use it in open domain question answering platforms. Also, maybe in some knowledge base integration for enterprise use. Also, you can, there is, for example, Perplexity platform, and the main concept of this product is retrieval augmented generation with large language model. So we can search for some information with specific documents. And it is really popular nowadays because we can improve not false answers of large language models, as we discussed, and create some robust platforms. It was the first topic which we will cover today, and we will explore how to create the system with Mistral API. Also, in the beginning, I want to discuss function calling and agent systems with you, because after retrieval augmented code, we will move to function calling, and we will create some function calling examples with Mistral library also. And maybe in the end of this lesson, I will explain you how to create agent systems, but I don't have specific example for this. I will show you function calling, which is really similar to this method, but also I will share you some specific libraries on which you can create agent systems, and we will search for some information. I will explain how to Google it, how to search information to create specific systems. So do you have any questions about retrieval augmented generation? I will wait for a minute. There is, okay, so no questions. Let's move to agents in artificial intelligence systems. So there is components that can perceive, reason, and act in environment. Also, it can operate often processing inputs. For example, we have text or sensor data, and we can perform actions based on this data. We can perform actions, for example, with using functions or integrating with APIs. And the goal of this system to create a system with a lot of capabilities, for example, like task ordinate behavior, when agents tailor to specific tasks, such as answering questions, managing workflows, or interacting with APIs, different APIs. For example, we have API for a text. Okay, we use OpenAI API for create answers with large language models, and also we have API of image generation, and we want to create the whole systems with multimodal approaches. Also, it's context awareness. We can maintain a history of interactions, ensuring coherent and contextually appropriate responses. And one of the most important capabilities of the system is tool integration. Agents can invoke external tools, as I mentioned, for example, APIs, and dynamically extending their functionality. So there are some examples of tool integrations, for example, fetching data from databases, processing payments, maintaining user accounts. And let's discuss how agents work, because I think for this moment it's not clear. It could be not clear. For the first stage, we parse input data via substructured or unstructured input from user, understand intent and extracts actionable components. For the second action, we will select action which we want to use in the moment. I mean, which our system want to use. We will decide whether to respond directly or invoke an external tool or function. In multi-tool scenarios, it may choose the most relevant tool, for example, in this moment. It's like making decision a little bit when our main agent create a decision in the moment to which agent it wanna move right now. And for the last stage, we execute and respond for the user. We execute action or call, for example, calling a function and combine the result with generative capability to produce a response. So there are a lot of good advantages of agents, but why we use them, it's because agents can be designed to handle a specialized tasks. Also, multiple agents can work together in larger systems, and enhance user experience by seamlessly combining artificial intelligence with external functionality. So it's interactive option of the system. And yeah, because of this, it's very popular. And also, like in virtual augmented generation, there are a lot of products that are based on agent systems. Also, there are some startups which create agent systems for using like a specific system for selling it to specific company, and right now it's popular. It's create good results, and it develop very rapidly. So do you have any questions about how we create agent systems? Okay, so the third aspect in this lesson about which I want to explain you before we will start create code or just run code blocks. It's a function calling, and in the beginning I want to create definition of this method. So function calling is artificial intelligence. I mean, function calling in artificial intelligence refers to the ability of language model to invoke predefined functions during a conversation or task execution. We have components in this like in this function, in this framework technique. For the first component in function schema, it's a structured JSON-based description of available functions. It includes function name, description of its purpose, and parameter requirements and types. Also, there is dynamic execution. The model notifies when to invoke a function based or on user input, and parses the necessary parameters and executes the functions. And integration with outputs, when we combine function result with conversational or task-specific responses, there are some benefits and some challenges in this technique. So benefits, it's the first one is that extends model capabilities beyond text generation, also reduces so we can mention input and output formats and enables real-time interaction with external APIs, databases, or systems. But there are some challenges like schema design when we requires careful planning to ensure clarity. Also, error handling. The system must gracefully handle functions errors or missing data, and context management when integrating functions results into ongoing conversations. So it's theoretical aspects of retrieval augmented generation agents and function calling, and all of these functions based on purpose of create a large language model more robust for user experience, and all of these methods help us to create some user products in the production with capabilities of large language models, and also with some mention of what is going on in this large language model in the moment. So do you have any questions about theoretical aspects of techniques which we will cover today? Is it clear? Is it hard? Maybe, I don't know, maybe you didn't understand anything that I explained, or maybe you understood all of the nuances, and we can move to the code of the examples of these methods. Okay, so if you don't have any questions, let's begin, and we'll begin from importing libraries. Here it's familiar, we familiar with these libraries. We used Mistral AI library to so it's this library provides access to Mistral API for generating embeddings, for example, handling channel conversations. And we used it when we discussed large language models, how to integrate it with API. Also, there is a request library that allows us to make HTTP requests, such as downloading data from URL. NumPy, you know this library. Maybe FAIS is not very familiar for you right now, but it's library which loads the FAIS, a highly efficient tool for similarity search and clustering of dense vectors. It's useful in search engines, for example, on a lot of in a lot of companies, in a lot of products, on marketplaces, on just agents, search engines in the internet, like Yandex, Google, and others. Okay, also we import OS library, a way to interact with operating system. And get pass allows secure input of sensitive information such as API keys without displaying it on the screen. I think all of these libraries are clear, and we used it sometimes, but if it's something new for us, for example, like FAIS, we'll try to create system with this component later. So I provided API key of Mistral for the system before we start lesson. So I showed you on previous lesson how to interact with their platform, how to create a key for user, how to use it, what shall we do on their site. If you don't know this information, just please watch the recorded video of that lesson. Let's move a little bit further to fetching and saving text data. So we create request, get requests with request library, which downloads text content from specific URL and extract the text content of HTTP resource this method. So let's move next. If all code lines are clear for you. If not, please ask. So we write our information to TXT file, and we can see length of our text, which we downloaded a few minutes ago. Our further steps is to chunk split document into chunks, because breaking large text into smaller chunks is crucial for processing with large language models, as they have a context window, limit context window, with maximum number of tokens which they can process in one pass, and we will use chunk size of 2048. It's popular context length of models. So we will create chunks, and we will see that we have 37 chunks. Here we split the full text into smaller chunks of 2048 characters, each creating a list. And here we just calculated the number of chunks generated. And we can see what was in our first chunk. Maybe if I will print it for you, it would be more beautiful because there would be a formatting of this text. Okay, so here we create embeddings for chunks. I will run this code because it would be not really fast. And here we see that our inputs of this function is chunks, the list of text chunks, batch size, its number of chunks to process at once, and yes, so also we will handle errors like rate limiting by retrying with a delay. And we will create embeddings requests. We call Mistral's embeddings API to generate vector representations for each chunk. And we also catch the and retries requests in case of rate limiting if we got this number of response or if there are other issues. So we convert textual information into dense numerical vectors that represent semantic meaning. And these vectors can be compared mathematically for similarity of clustering. We created, I think, for every lesson which we had in the semester, so I think it's similar for us. Also, we improve API efficiency and minimizing overhead by processing multiple chunks in one request with batching. Let's see shape of our embeddings. We see that we have 37 chunks, and they have hidden dimensional of embeddings of 1024. So we load, we create searching with FAIS with this tag code. So we can see FAIS index flat at this hotline. It's initialize FAIS index for fast similarity search using L2 distance. Also, we add the generated embeddings to the FAIS index, and we can create a further index search. Let me see. Okay, it's here. Yeah, index search. It search the two nearest neighbors for the question embedding, and it do it efficiency. So get text embeddings not defined, but let me see. Okay. 1 second. So let me explain you theoretical information about FAIS. FAIS performs its nearest neighbor search, critical for finding relevant chunks from large data sets. And L2 distance measures the distance between vectors to access similarity. Let's wait for a while. Yeah, so we have a question I'm waiting right now. And we can print something weird. I ran this code yesterday and everything was fine. Maybe let's rerun it. Okay, no worries. So let's open Mistral documentation. And here we can find specific example of creating okay, so yeah, of course we will have this issue. Okay, we have our result of nearest embeddings in our vectors chain. So now we can create a robust system which will answer the query, and with our retrieval generation pipeline, which we prepared with that functions that we realized now. Let's see which prompt we have here. So it's construct the input prompt with retrieved chunks and the user's question, because we will pass it to large language model, and we want our large language model to integrate with our results of the most similar documents in our chunks, with most similar chunks in of with yeah, most similar chunks to our question, and we will run. We will create function run Mistral, which sends the prompt to Mistral chat model and returns AI generated answer. We combine retrieval with generation components, and also here we have prompt engineering technique. It's not really prompt engineering, but we carefully designed the input prompt, ensure the model generates accurate and constant survey response. Retrieved chunk question. Let's see. Okay, so next we will run this function. It will our functional response to us, like large language model send a response, and then we want And yeah, we created retrieval augmented pipeline, and we can use it like this with face technique. Then we can move to function call and agents. Here we will have a function with similar the function simulates an API call to fetch user profile detail for a given user ID, and it will return a dictionary containing user specific information like user ID, name, and account status. In real-world applications, such a function would interact with a remote server or database to fetch details dynamically, and by explicitly defining function schemes, we can integrate such structured data retrieval in AI workflows. Here we will have JSON schema. We define a JSON schema for the get user profile function. It specifies the name, description, parameters, and required fields. For example, user ID of the function. JSON schema is a standard way to define a structure and validation rules for JSON data. And such schemas allows language models to understand how to call external functions effectively, providing structure and reducing abilities. So then we can, it's an example how to use it. We calls the get user profile functions with a simple user ID and returns the simulated user profile dictionary. This demonstrates a simplified interaction with user management system, and it will highlight, this example will highlight how AI can integrate the structured data for personalized responses. So then, yeah, there was block about some agents. We can move to creating payment data frame as a second example of function calling. Here we use pandas library to create a data frame with specific columns and rows with our data. It's dictionary simulating transaction data with fields like transaction ID, payment amount, and others. And we create data frame for structured data processing. Data frames here is necessary for data structures and allowing efficient tabular data handling. Also, tabular data often serves as input for feature engineering, analysis, or downstream machine learning tasks. And here we will define functions for payment retrieval. The first retrieve payments structures is a function which checks if the given transaction ID exists in the data frame. If found, it returns the payment status as a JSON string, and or else it returns the error message in JSON format. The second function is similar to the above, but fetches and returns the payment data. These functions simulate querying transactional data by ID useful for AI and customer services tools. And JSON is a lightweight format ideal for API responses, ensuring compatibility with various systems. Let's move to tool definitions. Here we define two tools for retrieving payment details, retrieve payment status, provides payment status, and second provide payment date. Each tool is described with its name, purpose, and parameter schema. Tools allows large language models to perform actions beyond text generation, such as calling external functions, and well-designed schemas ensures the model knows how to interact with these tools. Our further stage is mapping tools to functions. Binds the data frame to the functions so they can be called without repeatedly passing data frame. This approach links tool name to the respective implementations, enabling dynamic function calling, and useful for pre-configuration functions with fixed arguments. Now we can handle user queries. We simulate the user query asking for transaction status. It sends the query and tool definition to the model for processing and captures the model's output, which may include tool calls or direct answers. Large language model tool use can okay, so nowadays large language models can decide when and how to invoke tools, combining reasoning with structured actions, and yeah, we use these tools in our example. Then we create tool calling. It extracts the tool call details from the model's response and resolves tool call to its implementation and executes it with the specific parameters. Tool calls enable large language models to provide structured responses and delegate specialized tasks to external function. And then we finalizing the conversation. We append the tool result to the conversational history and then send the update history to the model for generating the final response. Maintaining history ensures the model has full context, allowing it to produce coherent and contextually accurate answers. And we can just get answer from the system, final answer, with our example of tool calling. So I think it's all the examples that we've had, and it was pretty simple, but if we'll build it in real companies, it would be heavier because we will have heavier schemas, and also maybe we'll integrate SQL responses. So do you have any questions on this not hard examples?
Do you use agents in your practice, in your business practice, I would say?
So I work in marketplace, and we create just specific recommendation systems based on large language models. We don't need agents and retrieval augmented pipelines. But in my scientist works, we used agent system to create a system which will robustness on chemistry data, and it was really useful in that topic in that area. Also, I know a lot of companies which integrate right now agent systems in their workflow, and a lot of companies which create agents for integrated in their systems with code, for example, copilots for code and others. Also, I wanted to give you an example how to create agents with Mistral workflow. Let me see. So yeah, they have documentation how to create agent, but it's necessary for create agent firstly on their platform, and then you can call it in your function with specific ID, which you will get after created in on platform. And also there is OpenAI agents library. Let me see. So I had example in a notebook. Yeah, here. Here is a library which is useful for creating agents. It's here. It's simple example how you can create agent systems. Also, when we created agent system on chemistry data, we used React tool, and here is blockchain library which integrates a lot of tools in one library. So they implemented React method too. But yeah, you can just memorize this this tool, and it's really simple for create agent systems to get decision in the moment to which agent you want to move. Yeah, you can search for more information in internet.
Thank you.
You're welcome. Any other questions? If not, you have this code in natural language repository. Oh, it's not that one. Yeah, this one. So it's 11th week. Here is notebook, and it was all our topics for discussion in this course. I will provide you information about exam in Telegram chat after I will get this information. And I think there is no time for last homework, but I don't know. I asked Radoslav about fourth homework, but for now you don't have any homeworks. And yeah, maybe other questions on which I can answer right now.
Yes, I actually have one question.
Yeah,
Is it possible to resubmit the second homework? I didn't manage to submit it on time, but in fact, I almost did it, and I had quite a normal result of 30 blue or something. And I expected we would have 5 homeworks. So, well, it will be fine, but it's just 3, and I am confused and anxious about my final grade.
okay. Send me your homework.
Okay. Thanks a lot.
I will check it.
I'll do it. In fact, I don't know why I didn't submit it.
Yeah, okay, no problems.
I just wanted to be much better, but it's still okay. Okay, thank you.
Okay, so if no more questions, we can just go for the rest on this evening. And thank you so much for your attention and for your questions.
Thank you very much.
Have a good evening. Goodbye.
Thank you. Bye.